All right, algebra class, we are going to review this. This shouldn't take too long, so I hope you will engage and have a good review here before the test. It is pretty similar to this one, so if you can understand the concepts on here, you should be pretty good, but I will do the other one as well. All right. Which situation could be represented by the graph below? Highly recommend that you look at the axes first. So this is our time. This is our speed. Make sure we're focused. All right, the speed increases and then decreases. Okay, so that implies an up-down motion. The speed increases and then remains constant. So the speed increases and then remains constant, so it would be B. It would be decreases if it went back down then. Number 2, a school secretary is buying pencils. The pencils come in boxes of 10, okay? So each box is 10 pencils. Sketch a graph to show the number of pencils the secretary could buy if she has enough money to buy 1, 2, 3, or 4 boxes. Okay, so we're going to sketch first. Tell whether it's discrete. Okay, so I'm going to underline them so I don't forget there's 2 parts to this. She is buying these. Okay, it is not legal to go into stores and rip boxes of pencils open and take only 2 out. You have to buy the whole box if you want to do that. So we have to buy them by the box. So this is going to be a discrete graph. I can tell right now because I can only buy 1 box, and that would be 10 pencils. Oh, we already have that. And then 2 boxes would be 20 pencils. And 3 would be 30. And 4 would be 40. And how high are we supposed to go? Let's make sure we included all of them, because sometimes there's a 0, and I would put it here. But if there's not, I'm not gonna. Sometimes there's a 5. So just read it really careful. Make sure you get every one of them. And again, I'm not connecting them, because if I put a point right here, that would mean that I have 1.5 boxes, and I'd have 15 pencils. Although that would be true, I can't buy 1.5 boxes. I can only buy 1, or 2, or 3, or 4. So I have separate points, and it is indeed discrete. All right. Hang on 1 second. I'm trying to look at something. I don't see it. Okay. So then we go to the next question, and it says, what is the range? So I know ranges, and you got to remember this, that the x values are which one? Domain. And the y values are range. They do go in alphabetical order, if you notice. A, B, C, F, G, H, I, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. A, B, C, D, E, F, G, L, M, N, O, P, Q, R. So if you line these up in alphabetical order, that's how you can double check if you think you forgot which is which. But I think most of you have it. So I am looking for the range. Make sure you put the correct one. So I am doing the Y values, and that's these. And then I list them all separately because I am given 4 separate values. So 0, 5, 6, 7, and that would be this. Tell whether the relation is a function. Which part did I say to look at? Only your x values. Are your x values different? Yes. Immediately you know, because then each x is mapping to 1 y. Every x has only 1 y. Now, if I added another one in here that was -4, it doesn't mean it's a no right away. it would be a no if this was anything other than -1. If I just happen to write the same point in there, that's still a function. I still have -4 and it's only mapping to a -1. But if I had, let's say, a +1, that would be no. But I want to get that off there so that it's not part of our question. All right. Draw a mapping diagram to show the relation. And then I also put in there a table and a graph, just so you practice with all three. Because you're going to do all three on the test, I believe. Pretty sure, I'm not. Yeah, I think you are. So the x values will always go in here, and the y values will always go in there. So my x values are 3, 6, 8. My y values are -1, 4, and 4. Okay, so I have the same one, so I don't have to write that 4 twice. And now I just got to make sure I draw the arrow to the right one. So 3 goes to -1, put the arrow on the end. 6 goes to 4, and 8 goes to 4. And we're done. All right, a table lists every point that you have. So I have 3, -1, 6, 4, and 8, 4. And then the graph is a graph of each of those coordinates. So 3, -1 is there. 6, oops, I'm off the graph. 4 is up here. And 8, oh, I'm really off the graph. Okay, 7, 8. Until I added this in. 8, 4. Do we connect them? No, just plot them. Well, good. So over here they had asked for the range, and right here they're asking you for the domain, and that was the x values. This is the one when you see a graph like this has infinitely many points. Okay, it doesn't just have 1, 2, 3, 4. It has infinitely many. You can't list them all. So we need an inequality, and since it's x values, I'm going to put the x in the middle. So it's going to be less than or equal to on either side. And now I need to use my ruler and see where it falls. So I'm going to start here, and I'm going to go over until it hits my graph, and it's going to hit my graph right, boom, -1, right? And it's still hitting the graph, still hitting the graph, still hitting the graph, still hitting the graph, still hitting the graph until it hits right there at 4. So my lower one, sorry about that, my smaller one would go here, which is -1, up to 4. So you're telling me the values on that x-axis. All right. Determine a relationship between it. So you're trying to first analyze and kind of look for a relationship between this value and this one. You know, what's happening. But here's the important thing. Once you determine that, you're writing an equation. Okay, and it typically is best if you just start straight off with y equals. Okay, so you're going to say y equals something. Well, we got to look here. Y equals, how do I get this? What do I do to this to get this? So y equals this. That's kind of hard to see, and maybe you see it. I do see it, but I'm going to move ahead because sometimes it helps if you go to the other end. Let's look at this. How do I get 2? If I'm supposed to get a 2 here, what do I do to get a 2 to this 4? I'd have to take away 2, wouldn't I? Does that work here? If I put it, oh, I should use my eraser board. Let's try it. If we subtract 2, do we get this? Yes. If I subtract 2 from my x, subtract 2 from the x, I will get the y. So typically it's trying to say, well, how do you go from here to here? I took away 2. And that's what you're doing to the x. All right, write a rule in, and here's the keywords. Function notation, that's like f of x notation. Airport is available for $8 per day. So f of x equals, and now you will tell me what the connection is. It's $8 per day. So since I'm using x, I'll use 8x. You could have put f of d, 8d. Okay, because if you want to pick D, which would be more relatable, it's saying if you put in 10 days, how much money would you pay? $80. But you can use any variable, it's fine. Glass of iced tea costs $2. Refills are 25 cents each. So, again, f of x equals. And then what are we doing? It's this. But then if you want refills, it is 25 cents each. Okay, so I could have done, what letter would make sense? I could have done f of r, standing for refills, right? So your price is going to be the $2 plus a quarter for every refill you get. Number 10. Remember, this is like a 2-in-1 problem. So you got two different problems. So you got what, figure it out then, and figure it out then. They're not connected to each other. So I'm going to take this over here, and I'm going to plug it in, f of, and I'm going to put the 0 in, equals 6 times 0 minus 1. Remember, nothing happens here. That just is notation. You're going to go over here and see what it is. 6 times 0 is 0. Minus 1 is -1. And that is your answer for that one. Now we got to repeat with this one, f of 4. Okay, again, notation, don't touch. Go to the right. 6 times 4 is 24. Minus 1 is 23. That is my answer for that. Two separate ones. All right, 11. What is the independent and what is the only the independent. Okay, so you're not getting dependent in this one. Eliza jogs more often in the summer months than in the winter months. So what depends on what? What depends on what? And this is your dependent variable, and this is your independent variable. So the time of year depends on how much she jogs, or how much she jogs depends on the time of the year. It's the first one, isn't it? Okay. Eliza jogs more often in the summer than in the winter. How much she jogs depends on time of the year. Table shows the number of runners in race for 4 years. Draw a scatter plot and a trend line. We got two things to do for that one. So first let's plot them. In the year 02 it was 21. Right there. 03 was 35. Right there. 04 was 46. There. 05 was 50. Right there. I can't really see very well. Oh, whoa. That is up. That's 55. I'm really not seeing. It's down here, isn't it? Okay. So I have drawn my scatter plot. Done. But I have not drawn my trend line. Remember, the trend line is drawn through such that it's going in the direction. So as you can see, it is going up, right? But this is years. So it's not necessarily going to go through this coordinate. This isn't 0, 0, is it? This is the year 01. Doesn't mean that there's no runners just because it's 01. So I want to go in the direction of it, and I want it to be such that it kind of goes through the middle of the pack here. Close to all of them as possible. Yeah, that was a very average line, let's just be honest. That could have shifted over a hinge so that it was a little bit more in the middle here. But, like I said, as long as it's in the ballpark, we're good. Drawing a line through here, no. Drawing a line through here, no. It's got to go in the direction of the data. Now, we're going to make a prediction. And remember, that's what trend lines are for. When we can look on here and look at 2007, It's right here, and I can go up to this, and now I can go over and see. So even though my trend line was kind of crummy, honestly, I mean, it wasn't horrible, but it could have been better. It's still, these are far enough apart that I had an idea. It's in that ballpark, so I knew it was 72. If there's one, and let me just actually check here. I want to see if I give you a multiple choice for the trend line. Actually, I don't. So you would go over here and you would say, I'd probably say 70. And I would get 100%. If this was you, you'd get 100% because I can look at your graph, go across and see. So I knew you drew the trend line pretty much right. And I go over and I see, and if you put this number for your answer, you got it right. Even if it's not quite the same number as somebody else put. I will look at their graph and figure it out. All right, good. We're getting there. Only 4 more to go. So we got to graph this. First of all, is this a discrete or continuous? Which one? Good. It is discrete because I give you specifically 4 values. So, again, this is D for domain. Those are your X values. So we're going to pop them in over here. -2, 0, 2, 4. Now I need to substitute them into my equation and see what my y is. So y equals 1/2 absolute value. And I'm going to use a erasable for this so that I can erase it. Okay, if I put a -2 in here. So I put a -2. The absolute value, remember, makes something positive. So the absolute value of a -2 is 2. So you end up having y equals 1/2, in this case, times 2. And that is 1. 2 times half is 1. Then we go in and put the 0 in. So I'm going to erase that. I put the 0 in. Absolute value of 0 is 0. 1/2 of 0 is 0. Now I'm going to put the 2 in. Absolute value of 2 is 2, right? Stays positive. Half of 2 is 1. Now I'm going to put the 4 in. Absolute value of 4 is a positive 4, stays positive, and a half of 4 is 2. So I need to go in here and plot these, -2, +1. Be just careful when you're graphing to make sure that you don't make mistakes. It's easy to do. And your graph should look like that. Now, do I connect them? No, because it is discrete. Right here. So I just want the 4 points. I didn't want any more. Okay, now we're on to this graph. And is this discrete or continuous? Very good. It's continuous. Okay, I don't give you the domain. I'm going to pick some values so I can graph it, but I didn't give them to you. I just gave you this equation, and there's infinitely many points on this. So we're going to go in here and pick. And we're going to pick the ones that I've always told you to pick. So -2, -1, 0, 1, 2. And we're going to substitute them in. Y equals negative something plus 3. So I'm just going to put in the -2 again. Okay, so -2, those multiplied together, it's like they're multiplying them. They become a +2. And then you get 2 plus 3, and that is 5. Then we're going to put a -1 in there. Oops, I'm jumping ahead here. Negative times -1 is a +1. 1 plus 3 is 4. See how when you're clear and you write your work down, it's much less likely that you're going to make a mistake. Put a 0 in here. -0 is still 0. 0 plus 3 is 3. Okay, I'm going to put a 1 in here. wow. See? -1. There's no other negative, so it's still a -1. -1 plus 3 is 2. And last, I'm going to put a 2 in here. -2 is still -2. Wow, that doesn't work so well, does it? -2 plus 3 is 1. So we're going to plot them. -2, 5 is up here. -1, 4 is right here. 0, 3 is right here. 1, 2 is right here. And 2, 1 is right here. Do I connect them? Absolutely. It's continuous, so it includes all the points on the line, not just these 5. And when you draw them, you're not even just going to do that. You're going to put the arrow on end, arrow on this end to imply that it's all the points on that line going forever and ever. Amen. All right. Now we have our arithmetic sequences, and let's see what we're supposed to do. Find the next 3 numbers of the arithmetic sequence. So we know that it is an arithmetic sequence, but let's see what the D is. So 3 to 7, they added 4. 7 to 11, they added 4, added 4. So we know that D is plus 4. So we're just going to continue on that train. 15 plus 4 is 19. 19 plus 4, 23. 23 plus 4, 27. It's A. What is the 22nd term of this arithmetic sequence? Okay, so you're going to be given the formula. You might know it already. Just got to put in the numbers. So remember, the n is the term you're looking for. So what's the term we're looking for? 22. Looking for the 22nd term. And this means, what is the first term? The first term means go up here and look at your sequence, and what's the first one listed? 12. So you take A1 out and you put 12 in. And then we have to put the n here. What was the n I put in here? 22. And D. I don't think we figured out D yet, did we? Let's go up here and look. 12 to 17 is plus 5, plus 5, plus 5. Our D is 5. So A sub 22 equals 12 plus 22 minus 1, parentheses first. Order of operations, we've got to do your multiplication first. 21 times 5. It's 105. So A sub 22 equals 12 plus 105. A sub 22 equals 127. Incorrect. 105 plus 12 is indeed 117. Okay, good thing. You got it. And I even did that. I double checked it. I was like, let's just make sure. 105, 12. And I was like, nope. So always do that because the little mistakes happen. Okay? So that's that. Not too bad. 24 minutes. And I'm going to cut this and then do the other one. And I'll send you both links. All right. Take care. Bye-bye.